My graduate work was primarily in a field called ubiquitous computing. This is a field of computing that's an academic research discipline, and it's something that's been very formative in a certain way of looking at user experience and user interaction in modern computer systems. And it is also, maybe a transitional stage as we were getting to cloud computing, or maybe cloud computing could be thought of as supporting ubiquitous computing as well. And so in this lecture, I'd like to give just a little bit of background on ubiquitous computing, as I think it's a useful lens through which you can look at user experience. There's also a lot of other reading that can be done to fill in some of the pretty sophisticated thought around this way of thinking about computing. So for starters, what is ubiquitous computing? Now, we could talk about it just in terms of the words themselves that are involved, ubiquitous being a word that means something that's present or appearing everywhere, things that are found all around us. We might say that the air is ubiquitous, or in this dictionary entry, we might say cowboy hats are ubiquitous among the male singers. We might say that. What we mean by it, though, when we say ubiquitous computing, is we mean a way in which computing becomes imbued in the world around us, so that everywhere you go, computing is part of the physical, mental, kind of experiential landscape in which you're participating. So in addition to ubiquitous just having this meaning, ubiquitous computing itself is an academic discipline. And the origins of it as an academic discipline or an academic field of study come from a paper authored by Mark Weiser in Scientific American called The Computer for the 21st Century. This article came out in 1991, which is quite remarkable as it predates the iPhone by almost 25 years, right? Yeah, that'd be right. And that's phenomenal given the state of the world then, because the things that Weiser and through the work that he was doing with his team at Xerox PARC, they were envisioning largely big parts of the world that we experience today. And that vision, the computer for the 21st century, came to be the field of ubiquitous computing generally. It's marked by a number of different ways of thinking about computing. Part of it is a technological trend. So Weiser was looking forward and seeing the shrinking of the transistors, the Moore's law, the increase in speed, the increase in transistor counts, and understanding that this was going to bring more power. But beyond looking at Moore's law, Weiser was also looking into thinking about how this would change the way in which we interacted with computers. And he made some predictions about how computers would come to be part of our lives and how we would start to work with them as a result. So part of the context that he put computing in was in 3 waves. And I'm going to add a 0 wave on top of that because I'm a proper computer scientist and we need to start with zeros as our counting. So some of the historical context for ubiquitous computing come from viewing computing as a series of waves. The 0 wave, one which Weiser didn't talk about, but I'm going to add in here, is basically what I would call computerless computing. This is the kind of computing that was going on maybe in the 1930s or 1940s, just rough time frames. And this was a time period in which computers were really theoretic technologies, things that didn't exist yet, but people kind of saw coming in the research labs, and the mathematicians, people who previously were mathematicians, were starting to become computer scientists without realizing it, by thinking about the ways in which these new machines were going to be able to compute. What sort of limits were there on the things that were possible to be computed? So people like Church and Turing were arguing questions about theoretical concepts like, does P equal NP or not? This question remains one of the great unsolved theoretical computing questions in computer science today. It's asking whether polynomial time algorithms and non-polynomial time algorithms, whether they're the same class of algorithm. So before there were computers, there were people working on the fundamental limits of computing. In many ways, this is analogous to where we are today with quantum computing. We have some fits and starts of quantum computing that are happening in research labs, but they're all very small computers, very limited in their ability to compute. And yet, there are theoretical computer scientists who are doing an enormous amount of work saying, well, let's imagine what the world would be like if we had these new quantum computers. What kinds of things would be possible to be computed? So again, this is a theoretical approach to quantum computing because we don't have those computers. Maybe we won't, but we certainly don't have them yet. But again, these two ways of thinking about the limits of traditional computing or the limits of quantum computing are different than what Weiser is talking about, because Weiser was really talking about the human's relationship with computing, in addition to the fundamental mathematical properties of computing. So his proper first wave was mainframe computing, the computing that became predominant in the 1960s and 1970s. Here's an image of a mainframe computer with a printer that was one of the primary ways of getting output from the mainframe. Very limited in their networked capabilities. They were huge computers that were in special rooms with raised floors and air conditioning, special power requirements. Very massive computers that did very simple data processing. Maybe in military contexts, they would be used to calculate ballistic tables. In business contexts, they might be used to do accounting or to do basic spreadsheet operations that we would think our watch could do now, or smartwatch could do now. Nonetheless, there were significant amounts of time and savings in being able to do these things on these large computers. And also probably a little bit of an investment in the future in being able to understand computing and where it was going. Nonetheless, in this first wave, there were very few computers in the world. Only the largest corporations and maybe some military scientific data labs were able to support them in terms of the infrastructure and the personnel and the training that was needed, and only those organizations actually needed the computing at that point. That's the first wave. The second wave then could be called desktop computing. This was the wave in which Microsoft rose to power. Happened maybe around the 1980s and 1990s. Again, rough boundaries around this time frame. And in this environment, business applications really drove usage, notwithstanding the fact that this is a picture of a computer mostly designed for playing games. In this environment, the business applications were causing people to have one computer per desk, at least in the office space. Gradually, this paradigm of desktop computing began to colonize homes as well, and it became typical for homes to have a computer that they would do, maybe bring home work from home or do communications, spreadsheet kind of tasks. Basically, they were all wired. They were wired in intranets, meaning that they had limited networks. An office would be connected through one network. A lab would be connected through a network. A college would be connected through a network. But it really wasn't the case that most places had been linked globally to the internet as we know it today. And all these computers were definitely wired. The idea of having wireless computing really hadn't arrived yet. Gradually, a new paradigm took over. This was a third wave, and this is what we would properly call ubiquitous computing. This wave started, again, maybe 2000s, lasting to the present. I don't think we've really gone past anything like ubiquitous computing yet. And in this stage, a different kind of demand was driving the new computing deployments and the new purchases of computers. And they were, driven by information creation, by access to the internet and access to resources online, and by communication, needing to communicate with other people through instant messaging, social media networks, things like that. So in this picture, you see someone with a early phone, still a feature phone, but taking a picture of a lion, perhaps to share it with someone, certainly to record it for their own memory. But this was a first, bow shot across the bow of what ubiquitous computing would look like. Small, handheld computer, available not for business use, not for a spreadsheet, not for any economic advantage necessarily, but for just what we start to see as part of a lifestyle of using digital technology. And it's starting to become something that is not very obvious that we're using computing anymore. In this stage, we started to hear terms like WANs and LANs, wide area networks, local area networks, PANs, personal area networks, largely supported by Bluetooth. Things like ad hoc networking. And definitely this stage was the stage of wireless computing. Now, an important thing that Weiser predicted in this third wave, this ubiquitous computing wave, was that computers would begin disappearing. Now, when you first hear this, you think, oh, well, they're getting smaller. They must be hard to see. We don't see them anymore. And certainly that was part of what he was saying. But a more important part of what he was saying is that the fact that we were using them was starting to fade into the background. The idea that these were becoming tools that were working so well that we stopped thinking of them as being something that we were working with and working on, and we started to work through them and started to work with them as if they were an extension of ourselves. Maybe an analogy to this is something like the way we use a hammer. When a hammer is functioning properly, and when you are hammering in nails, you don't think much about the hammer itself. You use it to drive nails, and until the hammer starts to get loose, until you miss the nail and hit your thumb, you don't really think much about the hammer. Or another analogy might be driving. If you are someone who has a driver's license and you drive regularly, you know that the process of driving, once you pass the beginner stage, becomes one in which you stop thinking about the controls in a way that's a little bit odd if you step back and think about it for a little bit. The car itself becomes an extension of your body. And when you want to go faster, you hit the accelerator. And when you want to slow down, you hit the brake. And when you turn the wheel and look in the mirrors. And after that initial learning stage, these behaviors become second nature, and the car begins to disappear. Of course, not functional, not literally. It doesn't become invisible. It's not Wonder Woman's invisible jet. But it becomes like a tool, like a hammer, such that we begin to work through it. And we stop thinking about it as something that we need to manipulate. We stop thinking about the steps we need to manipulate that. So Weiser anticipated that computers would begin to operate like this. We would stop thinking about the fact that we were using a computer, and we would begin to work through them, and they would become an extension of ourselves. Now, I think in many cases, we maybe haven't quite achieved that yet in the things that we think of as computers. Using Snapchat, using instant messaging, maybe looking up a location on a map, taking photos. I think that all still feels very present, like we understand, we don't forget we're working with computers. But that's exactly the point. There are plenty of places where we are working with computers where we completely don't notice it anymore. The ways in which our cars themselves have become imbued with computing. The ways in which our homes, in some degrees, have become imbued with computing, primarily through appliances, perhaps. The ways in which certain work gets done for us in databases, in finance, in informing us about different conditions through notifications. In those places, we are starting to stop noticing that computing is present, and it is starting to fade from view. Not because it's invisible physically, but because functionally it becomes invisible. So in the first wave of computing, the relationship between people and computers was that there were many, many people and one computer. This was the mainframe. So several people would log on to one computer in order to use it. As the second wave came along, there was a one-to-one relationship. There was a desktop computer. You would sit down to use it, one person, one computer at a time. Now in the third wave, in the ubiquitous computing stage, suddenly there are many, many more computers per person than there have ever been before. And that one person now has music players in cars, homes, office spaces, phones, maybe multiple phones, all interacting with their smart house, and all these different visions that we have of the way in which computing will be part of the fabric of our lives means that per person there are many, many more computers than there ever were before. Well, another point that Weiser wanted to differentiate his vision of ubiquitous computing from other visions was to draw out how ubiquitous computing was very different than another technology that even back then was hyped up very much, which is virtual reality. Now again, we're in a resurgence of the excitement around virtual reality, but the idea of ubiquitous computing, Ubicomp for short, and the idea of virtual reality are really very different kinds of visions of the world. So ubiquitous computing is mostly about computers leaving the domain of the computer and coming and starting to enter into the human world. And so what we see in this picture, what I wanted to draw out was the fact that the display changes as you turn the device. This is something that we've become very accustomed to, but if you think about it, that means that the computer is reacting to our world. As we turn the device physically, the computer responds to that and gives us a result that is appropriate for its physical embodiment in the world. Likewise, in the content of this video, in the content of this image as well, the map markers are being placed. We'll say that the map marker is being placed at where the user currently is. Certainly that's not something that's surprising. And to some degree, that's also the phone responding to the physical location of the device. A proper ubiquitous computing vision would say that as the computer went to a certain location, it would do work for you on your behalf without you really having to tell it to. The map's not quite doing that. But certainly turning the device is doing work for you without you really thinking about it. Now, augmented reality is somewhere in between. Let me come back to that. Let me touch base on virtual reality next. So virtual reality is different than ubiquitous computing because in virtual reality, what we're really asking the human to do is to enter into the computer's world. So in this image, we see the user donning a headset, putting on a haptic position tracking glove, or maybe two, and they've entered into a world in which the computer gets to dictate the senses and the views and the interaction. As you move your head, the computer gives you a new view to make it seem as if you've entered into this virtual world. And as you move your hands and the devices, different interactions happen in that virtual world, which have very little to do with the real world. And in fact, it's so disconnected from the real world that it's easy for you to pull on a wire and not expect to. It's easy to get fatigue in different ways because of the different weights that are being placed on your head and on your neck. It's also possible, if you're in a more mobile virtual reality setting, to run into walls as the relationship between the digital world that you've entered into and the physical world that you're actually in become unsynchronized, or they're just not related to one another necessarily. Also in virtual reality is the idea of the virtual world itself. So this is a picture taken from a virtual world system called Second Life. Has a new, has been resurrected as OpenSim. Professor Krista Lopes is one of the main developers on this Second Life. This is just a virtual world like you might see in any game. It's a user-created pathway to a house, but this is an example of what you would step into as you entered virtual reality. And then as we move towards talking about augmented reality, we can also talk about something which has been come to be known as a mirror world. And a mirror world is a virtual reality world that you step into, but that is designed to have a relationship to the real world that's kind of one-to-one. So this is an example of Google Earth, and Google Earth attempts to keep a very synchronized representation of the real world, and yet it is a virtual world. So you can go into Google Earth, you can move around using virtual reality metaphors and interaction techniques, but you're not moving through the real world in any sense. You're moving through a map, just an elaborate three-dimensional map. Finally, in the middle, we do have augmented reality. And augmented reality doesn't neatly fit into ubiquitous computing or virtual reality, because with augmented reality, typically the way it's envisioned, the way it's built out, is that you look at the world through a camera on your device. And so what you're seeing on your device is an image that's taken from the camera on the other side of the device. So you're looking at a screen that's showing you what's beyond on the other side of the phone. The reason why you do this is because as the image is being shown to you on the screen, it can be overlaid with virtual information that's somehow tied to your location or your viewpoint. So in this is an example of a virtual reality app that you can hold up and pan around the world that's near you, and the application will overlay onto that world little icons and information about what you're seeing on the screen. And there are various technologies that support this. Weiser wanted to say that ubiquitous computing was different than virtual reality because the computer entered your world, and in virtual reality, you entered the computer world. In augmented reality, it's something like a hybrid. The computer is acknowledging that it's existing in your world, but you're also entering into the computer's world. Maybe this is the boundary between ubiquitous computing and virtual reality. A little bit of both. So to summarize, computers enter the human's world in ubiquitous computing, and humans enter the computer's world in virtual reality, with augmented reality being. Well, a great question is, with all of these devices that are out there, with computers entering the world, that doesn't mean all of a sudden that there's no work associated with building the infrastructure of these computing systems. It has to be maintained, they have to be fixed when they're broken, software has to be patched and upgraded, and training, you have to learn how to use them, all these kinds of things. You have to update them and load them, and all the things that we've come to know and love about computers. Wow, what are we going to do to manage all of these computers? This third wave of computing that Weiser called ubiquitous computing. Where's that management going to come from? Especially the infrastructure on top of the devices themselves. Well, turns out one thing that Weiser didn't expect is that this was going to be managed by what I'll call the professionals, or basically what we've come to know now as cloud computing. And cloud computing will be the topic of the next lecture. So in summary, ubiquitous computing is a paradigm that envisions a particular way that people would relate to computers. It was a prediction about scale and the way that the relationship from computers would be many to one, one to one, and one to many, and what that would mean about how we would need to react, how we need to interact with computers in order to manage all the many computers that were around us. Weiser suggested it would have to become very natural for us to work with computers as we used voice and motion and physical layout in order to tell the computer what our intentions are. He also brought up a lot of philosophical background about the invisibility of computers and how that becomes an important part of his vision of what ubiquitous computing would look like, and all the things that result from those changes as well. So that in a nutshell is a very quick introduction to ubiquitous computing. I encourage you to read the original paper and a lot of the work that's been done around this concept since then. Thank you for your attention.